For this question, it says, Jamie has 2 boxes that she uses to store family photographs. Both boxes have a height of 4 inches, but one box has twice the volume of the other. How could this happen? Give the length and width of both boxes. So this is an open-ended problem, which means that students can have different answers to this problem. There's not just one correct answer that could apply here. So first, let's look at what we know. So Jamie has 2 boxes. We know that. And so let's just draw some boxes. 2 boxes. There's box 1. And then over here, box 2. So both boxes have a height of 4. I didn't really make them to scale, but let's just imagine they both have the same height. Both boxes have a height of 4. So, but one box has twice the volume of the other. Let's say that this box, since it's bigger, its volume is 2 times box 1. And then this volume is just half of that one. So how could this happen? We need to find the length and width of both boxes. So one strategy that you could do here is obviously to draw pictures and work it out that way, just like I'm doing here. But you could also work backwards. You could start with the volumes and come up with 2 different volumes and work backwards to find the lengths and the widths. So let's say we gave box 1, it would have to have something that is a multiple of 4 because you have to multiply that height into there. But let's say this has a volume of 16. If this one has a volume of 16, this one would have to be twice that. So 16 times 2 is 32. The volume of this box would have to be 32. So then to work backwards to find the length and the width, we know that volume is length times width times height. So then we came up with this volume of 16. Since there's a lot of different answers, you could come up with so many different volumes here. This one just has to be double this one. You could have so many different answers for the length and the width. But since this one's 16, we don't know the length and we don't know the width, but we know the height is 4. We could work backwards from here. So we could divide by 4 on both sides. We would get 4 equals the length times the width. And then you also have options here. There's 2 different factors that multiply to get 4. You could have 1 and 4, or 4 and 1, and then 2 and 2. I'm personally going to pick 2 and 2. So I'm going to say that the length and the width are 2 times 2 to get to this 4. So I'm going to say that the length of this one is 2, and the width of this box is also 2. We don't really have, oh, right, it's 4 inches. The units are in inches. So these would be inches too. So this is one possible answer for box 1, the smaller box. And then you'd have to come over here to box 2, which has a volume of 32. Length times width times height, which we know is 4. And then work backwards. So divide 4 from both sides. We would get 8 equals length times width. So then we have multiple options here. We could have 8 and 1, or 2 and 4, or switch it, 1 and 8, 4 and 2. So I'm going to do 4 and 2. I'm going to say 8 equals 4 times 2. So personally, just in my case, I would say that the length is 4 inches and the width is 2 inches. So The good thing about this problem is that it works on student reasoning skills because there is no one answer. Students will be able to justify their correct answers by proving that it works. So this allows them to enhance their critical thinking skills, their justification skills for their solutions. This is just one possible solution. There could be so many more. I could come up with different volumes for these. I could have said this one was 32 and this one was 64, or this one's 8 and this one's 16. As long as students are able to justify their answer and the numbers fall into the parameters of the problems, like they both have heights of 4 inches and one box is double the volume of the other, the answers could really vary and be anything. So the reasoning and the purpose of this problem really comes in students' ability just to justify what they did and provide and argue their correct answer.